Hello and welcome to this PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. Please remember, if you're joining us live, that you can ask questions throughout the webinar by clicking chat in the top left corner of your screen. And make sure that you change the to fields to include your name, school, or city so we can give you a shout out. Change the to fields so that it includes attendees or everyone. And also let us know your name, school, or city so we can give you a shout out when we ask your question. So today's guest is Dr. Mike Reid. He is a public outreach coordinator at the Dunlap Institute for Astronomy and Astrophysics at the University of Toronto. Thanks so much for joining us today, Dr. Reid. I'll let you take it away.
Great, thank you. So let me just share my screen with you. Okay, good afternoon, everybody, and thank you for coming. So, as Stacey said, my name is Michael Reid, and I'm a professor in the Department of Astronomy and Astrophysics at U of T and coordinator of public outreach for the Dunlap Institute. And today, I'm going to tell you a little bit about a topic that is of great interest to a lot of astronomers these days, and that's the topic of colonizing the solar system, and if we have a bit of time, maybe space more generally beyond the solar system. So I'll give you an introduction to the topic, and then afterwards we'll have a little bit of time for questions. So please plan your questions out and we'll have some chance to chat at the end. Okay, so many of you have probably encountered this idea before that humanity might one day spread beyond the Earth, and that there might be reasons for doing that. But I wanted to go over with you from an astronomer's perspective, what are some of those reasons for why we would want to leave the Earth and colonize other planets? So there are quite a few of these reasons, and everyone has, their own personal set for why they might want to explore another planet. But there are some more personal ones, and then some more kind of civilization level drivers for leaving the Earth. So some of those civilization level things include things like climate change. So as probably all of you are aware, we are undergoing a period of climate change on Earth, which is altering the planet. And while it doesn't pose any immediate risk of making the planet uninhabitable, it is certainly a concern that there are changes occurring to our planet and that we are causing some of them. And it raises the prospect of maybe someday wanting to think about having another place to live. So you can see some of those dramatic changes here in this picture of two different views of the same glacier before and after climate change, where the glacier fills the whole valley and then where it has retreated quite a bit. So we are having an impact on the planet that we're on, and at the moment it's not a terribly positive impact. That's one reason to think about potentially finding other places to live. Another thing that astronomers think about that maybe the average person doesn't think about quite so much is that over the long history of our planet, Earth has been around for about 4.5 billion years. That's 4.5 thousand million years. It has been hit many times by impactors from space. So you're seeing here an artist's rendition of what the event that caused the extinction of the dinosaurs might have looked like. So this is the impact of a comet or asteroid that would have churned a lot of soot and things into the atmosphere, which would have blocked light for a long period of time, sunlight from reaching the ground over much of the Earth, and that would have caused mass extinctions. Now, that was 65 million years ago, which may seem like a very long time, but 65 million years compared to the whole 4.5 billion year history of our planet is actually not that long. And so when we think on astronomical timescales, we think a lot about these kinds of events, and we know that they do happen every 100 million years or so. These very large mass extinction style events caused by asteroid or comet impacts. And from that perspective, knowing that there can be these devastating natural disasters on Earth, it makes sense for us to start thinking about, well, hey, it might be good to have a second planet that we can live on. Now, those are kind of the more negative reasons to want to leave the Earth, things to do with with the Earth itself. But there are some very positive reasons that astronomers think of to want to go elsewhere. And one of those is just the natural drive that humans have to explore. So many of you may have seen the film The Martian. This is a screen cap from that film. And you can just see the grandeur of exploring new vistas. This is obviously a very strong human drive that has led us to colonize almost the entire surface of our planet, excepting parts of the oceans, and drives a lot of people to want to leave the planet and go elsewhere and see what's out there. And we'll come back to Mars momentarily. Of course, something that astronomers are increasingly thinking about is not just going to other places that, as appears in this picture, might be dead, but going to places where there might be life. So we think about, going out into the universe and perhaps encountering strange little beings like this one, or even things much stranger than this little being. And it seems to me that we have higher odds of answering these fundamental questions of whether there's life elsewhere in the universe if we're able to actually go to other planets and explore them. So you may know the current way that we search for life on other worlds is largely by using telescopic observations and sometimes by sending robots, but only to very nearby planets. Of course, it would be really great if instead of sending robots, we could send actual people to go poke around on planets like Mars and see if there's any life under the soil or in various places we'll come to. So those are just some of the reasons why it might be interesting to think about leaving the Earth and living somewhere else. Now, what about reasons why we shouldn't do this? So there are a couple of reasons that people often float when astronomers and people who are enthusiastic about space talk about why we should leave the Earth. There are some reasons that people often bring up as to why we shouldn't. So one of those is that it would undoubtedly be very expensive to leave the Earth. Now, we don't know exactly how expensive because we haven't done it and paid for it, but people put estimates for the cost to leave Earth at something like $500 billion, which is such a large amount of money that it's difficult to imagine how much money that is. But to give you a sense of context, and one of the ways that astronomers often think about this question is $500 billion is a very great amount of money. It's a significant fraction of the annual budgets of most big countries. But it's much less than the total amount of money that the world's governments spend every year on just their own militaries. So from astronomers who tend to be sort of peaceably minded people, we like to imagine maybe someday diverting some of those military expenditures into more globally cooperative efforts to explore the universe. And from that perspective, $500 billion doesn't seem quite as expensive. Now, there's another big reason that people worry about with regard to leaving Earth and why we should or shouldn't do that. And you may know that in the history of Earth, when different cultures have come into contact, this has not always gone well. The history of people's encountering each other on Earth has sometimes been, very often been one of conflict. And so there's a significant number of people who would say that before we go and leave the Earth and potentially encounter other beings or other forms of life, that it makes sense for us to develop a little bit more here on Earth and think about how we would handle these issues of contacting other civilizations to make sure that those contacts go well. So those are some things I want you to have in mind. But let's say you've decided that it is worthwhile to leave the Earth and to go and colonize other planets. A big question we have is, well, where would you go? Particularly when we think of things like natural disasters that could affect the entire Earth, it seems, reasonably urgent to look to our nearby cosmic neighborhood to try and find places to go. And, it's nice to think about the very far future where maybe we might be able to colonize planets in other galaxies or planets, orbiting other stars. But for the immediate future, where could we go? And given the limitations of our ability to travel through space right now, the only places we can really get to within, say, our lifetimes would be planets in our own solar system. So which of the planets in our own solar system might we go to? Well, if you think a little bit about the planets, you probably know that there are 8 planets in the solar system, 4 small rocky planets, Mercury, Venus, Earth, and Mars, and 4 gas giant planets, we sometimes call them, Jupiter, Saturn, Uranus, and Neptune. Well, those gas giant planets aren't good places for humans to go, at least not as we understand them currently, because there isn't really any place to land and walk around. They're balls of gas and liquid, and you could maybe float around in their atmospheres, but there's no place to get out and land. So that leaves us with the rocky planets, Mercury, Venus, Earth, and Mars. Mercury and Venus are places people once thought might be good places to live, but we now know that they're both inhospitable. Mercury is very close to the sun and very, very hot, and as a result, it has no atmosphere at all, and undergoes extreme changes in temperature. It can be very, very cold at night on Mercury and very, very hot during the day. Venus is hot all the time, boiling, boiling hot all the time, because it has a very, very thick atmosphere that traps a whole lot of heat from the sun, and that keeps it way too hot for humans to survive there. So really that only leaves Mars among the terrestrial planets. So Mars is a planet that orbits a bit further from the sun than the Earth does, as you can see in this picture. And that means it's a little bit cooler than the Earth. The average temperature on Mars is sort of more typical of temperatures in the Arctic on Earth, but that's not too bad, right? People survive in the Arctic on Earth. You need some technology, you need some heating devices and warm coats and things like that, but you can survive there. And there are other properties of Mars that make it seem like a hospitable place that we might one day be able to live. So as I mentioned, the average temperature quite a bit cooler than on Earth. But one very nice feature of Mars that is not shared by any other planet is that the length of the day on Mars is almost exactly the same as the length of a day on Earth. It's about 24 hours, a little bit more. Now, that's quite different from most of the other planets. For example, Venus has a day, so sunrise to sunrise, that is 243 Earth days long. So that means that, day lasts about 6 Earth months, and then night lasts about 6 Earth months, which would be very uncomfortable to get used to, in addition to all the problems with the heat. But the significant downside of Mars is that the atmosphere on Mars is much, much thinner than the atmosphere on Earth. Now, let's talk a little bit about, what the effects that would have. First of all, let's look at this picture of the surface of Mars. This is a picture taken by a robotic spacecraft that has landed on the surface of Mars. And at first glance, it looks pretty similar to the Earth. It looks a little bit like any kind of desert climate on the Earth. It's got rocks and dust and sand and things blowing around in the foreground there. And then, some kind of sky in the background. But that sky is totally unlike the sky on Earth. It's not made of nitrogen, which is mostly what Earth's atmosphere is made of, or oxygen, which is what we need to breathe. It's made mostly of carbon dioxide, which is something that's present in the atmosphere on Earth, but not something we can breathe. And there's very little of it. However, there are some very nice features on Mars that make it an attractive place to live. So in addition to that approximately 24-hour day, if you look at this image of the whole globe of Mars, you can see at the South Pole there this white splotch. And that white splotch is actually an ice cap, quite similar to the ice caps we have here on Earth. Part of it is frozen carbon dioxide, which is normally a gas on Earth, but because it's so cold on Mars, it freezes out into an ice cap. And part of it is frozen water. So one thing we know already is that if we were to go to Mars and set up our habitation near that ice cap, we could melt part of the ice cap and use the water from that as our source of drinking water, and we could convert some of that water into breathable oxygen. So there are things on Mars that make it a good place to live. Now, one thing we've learned very recently about Mars is that although we know that in the distant past there was liquid water flowing freely on the surface of Mars, we haven't been sure whether that was still true. And in fact, we thought it probably wasn't true because it's so cold on Mars, it's hard to imagine how any liquid water could exist. But in the sequence of images I'm going to show you, you will see that we now have evidence that there is in fact small amounts of liquid water flowing very briefly, freely on the surface of Mars, which makes it seem a lot more friendly a place to go and live. So in this picture that you're looking down on top of the edge of a cliff. So on the right side of the image, that's the top of the cliff, and on the left side of the image, that's the bottom. And the image you're seeing right now is taken in winter, and I'm going to advance through 3 or 4 images here and show you as we go from winter into spring and into summer, you may see that something happens. So let me go back and do that again. So here's winter, spring, summer. What you hopefully are seeing is these dark streaks that make their way down the side of this cliff as the temperatures warm up on Mars. And what we have been able to determine is that some of those streaks are actually briefly liquid water that flows down the side of those cliffs. So that's great. It means that there may be liquid water even still on the surface of Mars today. Now, we know that there was lots of liquid water in the very distant past on Mars, so that billions of years ago, Mars would have been much more like Earth than it is today. So on the right, you see Mars the way it looks today, but on the left is the way it probably would have looked about 3 billion years ago. It would have had oceans and rivers and lakes and things like that. And what's very exciting about that is that there's some chance that life might have evolved in those oceans. And if it did, and if some of that water has remained liquid at least some of the time until today, then that life may still survive somehow on Mars. So it becomes very attractive to us to think about moving to Mars, sending scientists and people to Mars to do some exploration and look for signs of that life that may still exist there on Mars. Now, can we get to Mars? Well, I've already mentioned that it's very expensive, and the basic answer to the can we get to Mars question is yes, as long as we're willing to spend the money. So you may know that, in the past several decades, there have been many plans by different governments to get to Mars. And nowadays, there are even private corporations that are setting out plans to get to Mars. So this graphic here comes from the private company SpaceX in the United States, which are building rockets that they hope will go to Mars sometime within the next 10 years. Now, one of the things that they're working on is getting that $500 billion price tag down quite a bit, because $500 billion is a lot of money and would take a whole lot of international cooperation to get that going. But they hope that they can bring the cost of exploring and colonizing Mars down much below that, maybe by a factor of 10 or even 100, to make it much more affordable for us to think about going there. The big problem, as I mentioned, though, with Mars is that it doesn't have much of an atmosphere. So astronauts living on the surface of Mars would be exposed to dangerous radiations from space that the lack of an atmosphere means they are not protected from. And that would probably limit their ability to stay healthy on Mars. One of the things you would probably have to consider is living deep underground on Mars, where the soil and the rock above your head would protect you from those dangerous radiations from space. But that's possible. We could do that. Be a lot of technology, a lot of digging, but we could do it. That said, if you wanted to look for places where you wouldn't have to burrow underground to live, what you want to do is look to the moons of those planets that we kind of threw away before. So Jupiter and Saturn are not very livable themselves. They're big balls of gas, but they have moons which may very well be livable. So here is a picture of a moon of Saturn, and you may see if you look at the very bottom of this moon that there are little kind of fuzzy blobs coming out the bottom there. And what those are plumes of water. They're sort of geysers that are liquid water being shot out of the bottom of this moon into space. So we know that some of the moons of Jupiter and Saturn have oceans, but the problem is those oceans are frozen, or rather those oceans are buried under frozen surfaces. So this moon, which is called Enceladus, has a solid ice surface and then water hidden underneath it. There's a moon of Jupiter. Actually, there are several moons of Jupiter and a couple of moons of Saturn which are like this. So they have these frozen surfaces and then oceans deep underneath them. So we view those as interesting places for the search for life, but maybe not great places for humans to live. But we'll see. That said, I want to kind of leave you with this last possible place we could live. So this is another moon of Saturn. And what you see in the background there is Saturn itself with its lovely rings kind of shadowing the planet. But in the foreground, that brownish circle there, that is a moon of Saturn, quite a large moon called Titan. It's about as big as the planet Mercury, to give you a sense of scale. So it's quite a large moon. And Titan is a place that a lot of people think would be a great place for humans to live. So here's a close-up picture of Titan taken by a spacecraft that was sent to orbit it. And you can see the picture is a bit messy because we've only ever had one spacecraft go there, and wasn't able to take the best pictures, but here they are. They're pretty good. What you're seeing here is what Titan looks like under its thick atmosphere. Titan has a thick atmosphere the way Earth does. And underneath that atmosphere, it actually has lakes and rivers and oceans, basically, covering the surface, which is fantastic. If I show you this image here, you can actually see in the upper left sunlight glinting off those oceans, picked up by the spacecraft orbiting Titan here. So what you're seeing there is an ocean, but unfortunately it is not an ocean of water the way we have on Earth. It's an ocean of ethane and methane, which on Earth we think of as natural gas. So this is not the kind of thing you could, scoop a cup of and drink, but it is the kind of thing you could scoop a cup of and burn, which makes Titan an attractive place for thinking about having free sources of fuel, easy place to make rocket fuel and launch rockets to and from, because basically the surface of the moon is covered with something you could convert to fuel. The other nice thing about Titan is it has a thick atmosphere, like Earth does. So unlike Mars, where there is no protection from dangerous solar radiation, if you were to colonize Titan, you have this built-in shield against dangerous radiation from space, which is very convenient. Another sort of, kind of whimsical fact about Titan is that because it's smaller than the Earth, it has lower gravity than Earth. Still enough to hold you to the ground, but you definitely feel light on your feet. But because it has low gravity and a thick atmosphere, it would actually be possible on Titan for you to literally fly just by attaching wings to yourself and flapping. Your weight would be low enough that once you flap your arms in that thick atmosphere, you'd be able to push yourself off the ground. So it's kind of a fun place to think about going and maybe living someday. Okay, so very quickly, how about beyond the solar system? So you may know that nowadays astronomers are very actively looking for planets beyond the solar system, and we have discovered many hundreds of solar systems other than our own. So these are groups of planets orbiting stars other than the sun, and some of those may in fact have planets that are Earth-like. So that's what astronomers are focusing on a lot these days, is looking for planets that might be even more like Earth than Mars or Titan, but just orbiting another star. Okay, so that would take us a while to get there, but it's an exciting possibility for the future. So I will wrap up there and leave you with this question for you as you ask questions of me. Would you go to space? And if so, where would you like to go? Thank you very much.
Thank you so much for letting us know so many things about our own solar system and beyond. We certainly do have questions coming in already from some of our classes, but if you haven't started sending in any questions yet, please do so now. And we'll go with the first question, which was, what is the most habitable planet?
What is the most habitable planet? So, I mean, that depends a little bit on what kinds of priorities you place on different aspects of habitable, right? So the planet that is overall the most like Earth is Mars, in the sense that it's got some water, it's got decent gravity, it doesn't have a toxic atmosphere or anything like that. But it would still be fairly tricky to live there. So, conventionally, the answer to that question is Mars, but increasingly some people are saying, you know what, the problems with the atmosphere on Mars are so difficult that maybe, even though Titan is a lot less like Earth, maybe we should think of Titan as the more habitable planet. So it kind of depends a little bit on who you ask and what their priorities are.
Right. Well, that brings us to a question we have from our grade 9s in Armstrong, BC, asking how long would it take to get to Titan or Mars?
So we send a spacecraft to Mars quite often. There are expensive ways that are faster to get to Mars and cheaper ways that are a bit slower, and we usually do the slower, cheaper way. And when we do it that way, it takes something like about 1.5 years to get from Earth to Mars. And kind of what you do is you wait until Mars is on the other side of the sun from the Earth, and then you sort of drop your rocket towards the sun, and it kind of slingshots around the sun and reaches Mars. And that takes a little while, but it means you don't have to bring a lot of fuel because you benefit from the sun's gravity. So doing it that way takes a little while. But, 1.5 years to get to Mars, maybe that's a fair trade-off for some people. For Titan, it would be considerably longer. Again, you can do a more expensive way. If you have zillions of dollars to throw at it, you could get there faster. But, more reasonable estimates for getting to Titan would be sort of in the 5 or more year range.
Interesting. Well, our next question is from Brantford Collegiate Institute in Brantford, Ontario. They're wondering if our moon would be habitable.
So would the moon be habitable? Yeah, in a sense. I mean, humans have already been to the moon. It's been a long time since we've been there, more than 40 years. But humans have already been to the moon and survived fine. It doesn't have as many convenient resources as Mars does. So it doesn't have any atmosphere at all, not even the thin one that Mars does. And it doesn't have much in the way of water. But it does have some things that, would make it reasonably habitable. And it has the advantage of being close enough to Earth that we could ship supplies there without too much difficulty. So yes, we could live on the moon. And in fact, there are many countries that are thinking about doing that.
Interesting. And Bragg Creek would like to know, what would we need to do before we colonize any planets or moons other than Mars?
So right now, we have most of the technologies that we need to get to another planet and stay there for a short period of time. As long as we're bringing food and supplies from Earth, we can do that now, as long as we're willing to spend the money required to build all the equipment and launch it all to Mars or the moon. But if we want to stay there for a longer period of time, we don't quite have all the things that we need. So, for example, one thing we would need if we wanted to stay on a planet would be some way of growing food. It would be very, very expensive and a bit risky to constantly send food from Earth. So we would like to be able to grow food locally, and we don't yet know how to do that well and without constant refueling from Earth. So that's a big technological limitation.
Next, we have a question more about you from Chinook Park School, wondering if you have ever been to space.
I have never been to space. So I'm an astronomer, and astronomers are people who study space from Earth. And astronauts are they're the people who get to go to space. And a couple of them have been astronomers, but most astronauts are medical doctors or engineers or sometimes other kinds of scientists. And those are the people who usually get to go to space.
Right. And speaking of space, another question from Chinook Park School, wondering how cold it is in space.
Okay, so in space itself, actually, it's a funny question to answer how cold it is. So normally, if you go outside in the winter and you don't have your jacket on, the reason you feel cold is because the air is cold and the air touches you and kind of robs heat from your body. But in space, truly in space, not on the surface of a planet, there is no air. There's almost nothing. So there's nothing to kind of steal heat from your body the way the air on Earth does. In space, what cools you down is the fact that your body is just constantly radiating heat away. It's bleeding heat away into space, even when there's nothing to come and steal it. But that takes a long time. So if you stayed in space for a long time, your body would cool down until it was several hundred degrees below zero, very, very, very cold. But it would take a little while before it got that cold. And you'd have other problems long before that happened, of course, like the lack of air.
Just a little problem.
Not problem, no air, yeah.
So just trying to figure out which question to go to next here. We've got lots of questions, and that is wonderful. Keep them coming. A few students wondering about that comparison you put up on a slide between Mars a billion years ago and Mars now. And that Mars a billion years ago looked so much like our Earth in that artist's rendering. So we have a question from Quinn in Comox asking what caused the temperature to change on Mars?
Yeah, this is very important for us to understand. So a lot of what astronomers do in understanding planets is what we call comparative planetology. And that means you look at two planets and you compare the differences between them to try and understand why they may be similar or different. So when we look at Earth and Venus, we see that they are very, very similar. They're almost the same size. They have almost the same amount of gravity, made of the same materials, and yet Earth is nice and comfortable, and Venus is blisteringly hot, a terrible, terrible place where, even the robots we send there melt. And Mars is a very cold place, and also smaller than the Earth. And when we look at all of these facts, we are able to piece together a very clear picture that what has happened is that planets like Earth and Venus are big enough that their gravity holds the atmosphere to the planet. It keeps all those gases close to the planet, which can keep the planet warm or even very hot in the case of Venus. But Mars is quite a bit smaller than the Earth, so it has less gravity, and it doesn't have, Earth also has a magnetic field, this kind of force field that protects it. And Mars doesn't have that, also because it's small. It's too small to have that magnetic field. And those things, that combination of things, the low gravity and the no magnetic field, means that over time, Mars's atmosphere left. It escaped into space. So it used to have a lovely thick atmosphere that kept it warm and made it possible for there to be oceans, but that atmosphere has bled away into space and is basically gone now. But that won't happen to Earth because Earth is plenty big enough to hold its own atmosphere tightly and keep it in. So Earth will not turn into something like Mars anytime soon.
And you answered my follow-up question before I got to it. We had some students wondering if we were headed down the same path as Mars. So instead, I will go to something completely different and will ask if the robots that visited Mars found any fossils or evidence of life.
Yeah, so there are robots on Mars now. There are always robots on Mars these days. There have been for since the mid-90s. And we're always sending new robots to Mars because Mars is the planet that is the most likely, we think, to have life like us, or life like Earth life anyways. No humans, but maybe bacteria that are similar to the ones that live on Earth. And have they ever found evidence of life? Not directly, no. They've never found a fossil that we're sure of. And they've never found any direct evidence that there is life. They've never sort of scooped up a handful of soil and gone, oh, look, bugs, or something like that. But they have found a couple of, very, very tantalizing little hints, like the liquid water that we know is essential for our kind of life. And they have occasionally found signs of some gases on Mars that, at least on Earth, tend to come from living organisms. So the fact that those gases are there kind of suggests that there could be life there, but we also know some of those gases can come from purely geological processes, chemical reactions of rocks and things like that. So it's uncertain, and that's one of the reasons why we want to send humans there to do longer, more detailed studies of what's going on Mars and see if there's life.
Right. And now I would like to ask a question from Ms. Wally's class at G.A. Brown Middle School, wondering why colonize space when we could clean up Earth?
Yeah, and that's a great question. So that was right where we started, right? If we know already that we're having a damaging impact on the Earth, rather than just ditch Earth and go somewhere else, why don't we clean up the Earth? And I would say absolutely, we should definitely clean up the Earth, for sure. And cleaning up the Earth will be great. It will solve problems like climate change and all the other kinds of pollution issues that we have on Earth that pose threats to some kinds of life. But cleaning up the Earth will not help with a lot of the other issues. So, for example, it won't help with the risk of asteroids, which we know to be a very real risk. No matter how clean the Earth is, it can still be hit by an asteroid or a comet, and that's something we can't currently control. And similarly, it also won't help us answer questions like, is there life anywhere else in the universe? So I think most astronomers are very, very strongly in support of cleaning up the Earth and making sure that it remains a good place to live for as long as it possibly can. But we still think there are good reasons to go elsewhere.
And that's interesting because that makes me think of a conversation we had previously about a person who is, I'm trying to remember the title, basically a planetary guardian. Can you tell us about that?
Yeah, so you're referring to the Planetary Protection Officer,
Yes.
Which is a job at NASA. And this is somebody who makes sure that life from Earth doesn't go to other planets and contaminate or destroy life on those planets. And similarly, that life from other planets doesn't come to Earth and contaminate or destroy life on Earth.
Right. So there are definitely people who are keeping in mind not only the health of our planet, but all the other planets as well, which is something I had never thought of before. So in that vein of potentially asteroids coming to Earth, something like that, Morgan in Comox Valley would like to know what causes meteor showers.
What causes meteor showers? So the solar system is full of billions, maybe trillions, a very large number of kind of stray rocks and comets and things like that. And most of them are quite far from the sun, but not all of them. So some of those comets, in particular, they come in close to the sun, and you've probably seen pictures of comets, and you know that they develop these lovely tails. Those tails are gas, but they also have little bits of ice and rock strewn in them, tiny, tiny little pieces. And when those comets come near the sun and they pass around the sun and they shed those lovely tails, over time, Earth can eventually pass through some of those tails. And when it does, you get this sort of rain of those little bits of ice and dust and things falling down on the Earth, and they burn up in the atmosphere, and that's what causes a meteor shower. So those aren't harmful or a risk to Earth. They're happening all the time, and they're just nice to look at.
So a nice number question for you now from Chinook Park School, wondering how many planets are in the universe?
How many planets are in the universe? This is a favorite question for astronomers because we would like to know that very, very much. So until the early 90s, we didn't know of any planets anywhere in the universe other than the ones in our own solar system. And so that was it. As far as we knew, there were, well, then we counted Pluto as a planet. So there were 9 planets in the universe. That was all we knew. And that's all we had known for thousands of years. But in the mid-90s, we started to discover planets orbiting other stars. And now, having looked very closely at many other stars for decades, we know that most stars have some planets. We don't know how many planets, but some anyways. So if you think about the Milky Way galaxy, the galaxy we live in, it has about 400 billion stars, 400,000 stars. And each of those maybe has somewhere between 1 and 10 planets. So that's all, maybe 4 trillion planets right there. And then that galaxy, our own galaxy, is just one of hundreds of billions of galaxies in the universe. So if you start multiplying all those numbers together, you very quickly get a number that's very large and hard to communicate. But it tells us that there are an enormous number of planets in the universe. It's truly hard to even express the bigness of the number.
Yeah, it's quite mind-boggling to think of how many places we have yet to explore. I think we should wrap up here, but before we do, I would like to ask if there are any students who are really interested in this and perhaps following in your footsteps to be an astronomer, or if they're interested in maybe even trying to be one of those people who does visit Mars or go up into space. Do you have any advice for them for what they can do from here?
Yeah, absolutely. So if you're interested in studying space or maybe someday going to space, you want to stay focused in your education on science. So make sure that, you study hard in your science and your math classes. And when you get into high school, if you're given the choice to take some science courses, make sure you do those. And then when you someday get to university, you can study any science. Any science can get you prepared for some astronomy. But often people will study physics or chemistry. And these days, with an increasing emphasis on the search for life elsewhere in the universe, even biologists now do astronomy and look for life elsewhere. If you want to be an astronaut, usually astronauts are people, as I say, like engineers or medical doctors or pilots, things like that. So, if you're thinking someday you might like to leave the Earth, you should, think about getting a good degree in some practical subject like medicine or engineering and learning to fly.
No small feat.
No small feat,
yeah. Well, that is all the time that we have. Thank you so much, Dr. Reid, for joining us today and answering all of our questions.
You're very welcome. Thanks for coming, everybody.
Just to let everyone know who's with us today, we have upcoming PIR live event webinars on bendable electronics, Canadian history, and coding, to name a few. More information about these and other educational programs from Partners in Research Canada is available at pirweb.org. Thanks so much for joining us, and have a great day.